Question 26a, Part 1. The number of bacteria in a culture grows from 100 to 114 in 1 hour. What is the percentage increase in the number of bacteria? The first thing we need to find is the increase in bacteria in 1 hour. So starting with 100 bacteria, and after 1 hour it becomes 114 bacteria. The increase in bacteria is the difference between 114 and 100. So this is given by 114 minus 100, which equals 14. The next step is to determine the percentage increase. And that is found by taking the increase in bacteria that we just found, which is 14, and divide it by the original number of bacteria, which is 100. And then we times that by 100 to convert it into a percentage. So 14 over 100 multiplied by 100, then we add the percentage symbol at the end, equals 14%. Part 2. The bacteria continue to grow according to the formula n equals 100 times 1.14 to the power of t, where n is the number of bacteria after t hours. What is the number of bacteria after 15 hours? Substitute 15 for t in the formula n equals 100 times 1.14 to the power of t. So replacing t with 15, the formula becomes n equals 100 times 1.14 to the power of 15, and using your calculator, that evaluates to 713.79 and so on, which is approximately 714 correct to the nearest whole number. Therefore, the number of bacteria after 15 hours is 714 correct to the nearest whole number. Part 3. Use the values of n from t equals 0 to t equals 15 to draw a graph of n equals 100 times 1.14 to the power of t. Use about half a page for your graph and mark a scale on each axis. The following is a sketch of the graph of n equals 100 times 1.14 to the power of t. It takes up roughly half an A4 page. The scale that I used on the x-axis is 1 centimeter equals 1 hour. And the scale that I used on the y-axis is every 2 lines equals 100 bacteria. Notice that I've marked in key coordinates on this curve, and these coordinates come from the table of values. Notice also that I've written the formula near the line, and that's good practice to label the line. Also notice that I've labelled the origin here. I've labelled the x-axis, which is represented by the pronumeral t because it represents time here. And the y-axis is labelled with n since it represents the number of bacteria. Part 4. Using your graph or otherwise, estimate the time in hours for the number of bacteria to reach 300. To estimate the time it takes for the number of bacteria to reach 300, first locate 300 on the y-axis, since the y-axis represents the number of bacteria, then draw a horizontal line all the way across until it strikes the curve n equals 100 times 1.14 to the power of t. This was the curve that was drawn in part 3. It's important that the horizontal line that's drawn is parallel to the x-axis. At the point of intersection, draw a vertical line downwards until it touches the x-axis, and it's important that this vertical line is parallel to the y-axis. And at the point where the vertical line crosses the x-axis, we can estimate the number of hours it takes for the bacteria to reach 300. And at this point here, it's approximately 8.4. So from the graph, it takes approximately 8.4 hours for the number of bacteria to reach 300.